Okay, so I'm here to talk today about the future of the web. This is obviously a very large topic, and so I'm going to narrow the focus down to one particular trend that I think is very interesting and something that I think, if you understand it, will really help to shape your understanding of all the things that are happening on the platform, all the news that you read about the platform. So first of all, you might be asking, why do I have anything to say about the future of the web? Honestly, I don't really. I have no special insights into it, but I am involved pretty much up and down the stack in terms of web stuff. So I have a company that builds web applications, but I also work on a web framework. I'm also involved in the standards organizations that make JavaScript and also the technical advisory group for the whole W3C. So I'm pretty actively involved in a lot of parts of what's happening in standards, and I think I'm pretty uniquely suited to give a sense of what the big picture is. So in the early 1800s, France was undergoing a lot of turmoil. And between 1800 and 1830, there was a lot of political upheaval. But one thing that they did manage to get right, one thing that they did manage to get done at least, was their canal system. And then they woke up in 1830 after spending decades on their canal system, and they noticed that nobody cared about canals anymore, and said, what we really need to do next is we need to build a series of railroads. And they said, the way we're going to build this series of railroads is we're going to do it centrally. We're going to start from Paris, and we're going to build very straight lines, very centrally managed lines across the entire France. And we're going to be very careful about not involving any local areas. We're going to do straight lines. We're not going to have a lot of redundancy. We're going to build something that's fast, that's efficient, that we can centrally manage, centrally control, that radiates out from Paris. And they actually did manage to build a very nice technical achievement of a centrally managed railroad system. But in 1870, when Bismarck invaded France, they ended up getting the worst for it because while the Prussians had a very poor railroad system from the perspective of elegance and beauty, it was not centrally managed, it had a lot of redundancy, it had a lot of complexity. It was very easy for the Prussians to reroute around parts of the system that got nuked, well, not nuked in 1870, but that got destroyed. While in France, if you took out Paris or you took out part of the system, it was very difficult for people to actually go from one place to another. So this railroad system, which is known as the Legrand Star, after the creator Victor Legrand, seemed to have all the benefits of a nice system. It was built by the greatest minds, the biggest minds, but it didn't end up working. It didn't end up solving the problem because of the fact that it ended up being much too centrally managed, and it ended up losing to a system that was much more ad hoc, that was much more ugly, that was much more redundant, but it ended up working. This story comes from a book called Future Perfect. I would recommend reading it if you have not. And I read this book sort of as I was thinking about giving this talk, and it really helped me understand the trends that are going on in the web platform. So one thing that's really great about the web platform in general is that it started off as a decentralized system. Anybody could write a website. Anybody could put a website on the network. You don't have to get permission from anybody. There are very, very few central systems. And this was a really, really nice aspect of the web system. It was sort of like the Prussian railroad system. It was ugly, wasn't elegant, wasn't like go for centrally managed, you have to get permission to get a link in, maybe you had broken links, but at the end of the day, there's a lot of redundancy, many copies keeps things safe, etc. But somehow, when we got past the initial web and we started doing standardization, we've actually gotten into a bad place, which is that we've now created our own Legrand stars in the standards process. So because of the fact that the web browsers needed a place to coordinate centrally, and because of the fact that there's so much craziness in the existing implementations of web browsers, what has ended up happening is that for the past 5 or 10 years, the innovation has been driven centrally through the HTML5 process, and it has given us a lot of good things, it has given us a lot of progress, but it means that we're spending a lot of time trying to centrally manage innovation in areas where it may not be appropriate. So here is one example. There is a thing called main content, which eventually became content. A lot of centralized effort and energy was spent standardizing main content. It even got its own Bugzilla component called the main content component. All this for a single tag. So many people were centrally trying to manage whether or not people should use a main tag in HTML. And remember, you can use a main tag if you want just fine. All browsers don't care. But the standards process found itself in this weird position where it was trying to decide whether or not it made sense for everybody to have a main component. And what ends up happening is that we spend a lot of time trying to centrally manage these things, and then we end up with people who want to do something a little bit different. So for example, if you want momentum scroll on a mobile application, you end up having to rebuild tons of the entire layout system because we built a very centrally managed, well-understood system that is designed for particular use cases, and if you don't have those exact use cases, there's really no hooks into the system. You basically have to go and start from scratch. You have to build your own scrolling system if you just want to get a little bit of momentum scroll. Now, it hasn't always worked like this. Historically, we've actually had a lot of good libraries that got created to build on top of things that were already in place. So jQuery is a really good example of this. There was a lot of stuff that the DOM didn't do exactly as we might have liked. The API wasn't very good. It was hard to use, confusing, didn't compose very well. And we were able to basically solve that in libraries, solve it in a library space. Another example of this is the picture element. So as you probably know, Retina displays are becoming very popular on the platform. And obviously, HTML5 didn't think of dealing with Retina displays ahead of time. It had to be dealt with quickly. And people who were in the responsive design community basically said, okay, we have a solution, we have this picture element, and they tried to go to the standards process to get it standardized. So they went to the CSS working group, they went to the HTML working group, and they said, we have this proposal for a picture element. And of course, immediately everything stalled. There was an argument. The HTML guys said they wanted to do it a different way than the way the people who had spent the last year trying to work on it wanted to do it. And I don't really know who's right. But what I do know is that at the end of the day, what happened was the guys who were working on the picture element basically just went and wrote a library. They wrote picture fill, which works exactly the same as the picture element is supposed to work. It's written in JavaScript. It's only 20 or 30 lines of JavaScript. And it actually solves the problem. And so we, as a platform, as a web platform, are most effective when we enable this type of innovation. We're most effective when Retina displays come out and we need a quick solution. We're most effective when someone could write 20 or 30 lines of JavaScript and actually ship something and not have to spend years arguing with standards bodies. Now, there's one really, there's a visceral thing if you've been doing this stuff for a while, which is that if you actually try to build something like jQuery or picture fill, often it really is terrible. It doesn't feel good. You end up hacking in deep. You end up having to touch areas that have nothing to do with the area that you're dealing with. If you build a picture library like picture fill, it probably doesn't play that well with other libraries that maybe are doing similar or even not very similar things. You have to be careful about how you listen for events. So this whole thing, while it has produced a lot of innovation in a decentralized way, things like jQuery, picture fill, and many, many other libraries, actually doesn't feel good to write. It's not something that many people can do. It's something that you really have to be an expert to do. And I think, as a general rule, web developers, front-end developers, prefer a decentralized design. We prefer when we have the appropriate hooks that are necessary to go in and surgically do something. So actually, the picture fill library does make use of a few surgical hooks that make it pretty easy for it to do its job, some of which are pretty new. It could be even better, and I'll talk about that later. But things like jQuery actually have to get pretty invasive. Things like Polymer, which is a new Google library which tries to add in support for custom elements, gets pretty invasive. So really what we prefer is a decentralized design. We like things like picture fill, and we like things like jQuery. And we prefer them over having the platform argue about how to do a particular API. So obviously the platform is necessary to expose certain capabilities like hardware support or an HTML parser in the first place. But in general, we prefer to have libraries do these things. So why do we prefer to have libraries do things? I think it's self-evident, but I'm going to lay out a few of the reasons. One of the reasons is that it lets the whole platform iterate without risk. So if you talk to web browser vendors, they often use the phrase, don't break the web. And what they mean by that is that it's very hard for them to add new features to the platform quickly because of the fact that once they add a feature to the platform, it becomes very hard to take it out. So even things like the WebKit prefix CSS properties or WebKit JavaScript APIs are very hard to remove because people have come to rely on them. And then maybe Firefox has to implement WebKit prefix things simply because the web has come to rely on it. So browser vendors actually it's very difficult for browser vendors to add new features quickly, even in cases where there's some urgency, like the case of responsive design. Experimentation via libraries doesn't really have this problem. If you can experiment via libraries, then you're in a pretty good place. Another really good reason why we like libraries is that they allow us to solve domain-specific problems. So we have some cases where we just hard-coded them into the platform, like MathML. You can write math in HTML, basically. But there's a whole long tail of domain-specific problems that really should be solved not in the platform, but should be solved by someone who has expertise in them. And you don't want to bottleneck that into the standards process. Eventually, after jQuery existed for a really long time, the browser was able to standardize around the selector engine, and they created a feature called Query Selector All. Because of the fact that jQuery had already, and other libraries had already iterated on selector engines, it was pretty easy to see what the API should look like. So the browser vendor didn't have to guess what the API might look like and then clunkily iterate as people maybe didn't like it. The browser vendor was able to basically take a look at what the libraries had done over a couple of years and then bring the feature in with native support. I think one thing that's quite important is often it feels like there's urgency to get some stuff done. So for example, responsive design again, or offline support feels very urgent. And often that causes the standards process to want to standardize around a particular scenario. So you know about a particular offline scenario, so you solve it using a particular solution. And then if somebody doesn't have that exact scenario, they're kind of stuck. They have to go back around the standards wheel and convince somebody in the standards process to add another scenario. So really what we would prefer is to have a few basic primitives in the platform and then allow libraries to experiment, to explore, and not rush the standards process into making a decision that they're going to regret later. And finally, I think in general, the way you should think about all of these things is that they allow us to have a better feedback loop between people writing JavaScript code or platform code and people designing the platform. Right now, the feedback is try to put something behind a flag in Chrome. Hopefully somebody will look at it. Obviously you can't ship it to users. 6 months later, you probably get a little bit of feedback. Maybe if everyone agrees, you can advance it into the main stable branch. Hopefully it's not too late to fix things at this point now that it's in the real world. You get some feedback. You have to be very careful about what you change. Of course, all these things don't exist in libraries. So if a browser vendor was to make a library, like Google has done with Polymer and Mozilla has done with Xtags, it's going to be a lot easier for the browser vendor to learn things that they made mistakes about, and they'll be able to quickly change it. And if you don't want the new version of Xtags, just keep running with the old version of xtags.js or polymer.js. So we can get a lot tighter of a feedback loop. We can explore ideas that browser vendors have, because frankly, browser vendors have a pretty good sense of what the platform needs, but they don't always get the API right. And just to go back around, I think all this stuff sounds great, but in practice, it sucks to write the code. It sucks to write the code. So really what I'm here to tell you is I think a lot of what the platform is doing over the past year or two and over the next few years is going to be making it suck less to have this type of flow, to have this type of workflow. And I want to use a particular concrete example about app cache. So app cache is this feature that the browser created in order to support offline. And you can go look at it over here. There's a thing called offline web applications. So there's a centrally planned Lagrange star. Here is how you should do offline applications. And there's many pages here and a lot of thought that went into it. So we get, and this is a common pattern in the browser, we get centrally planned new capability. So we have a new capability, which is the ability to serve an HTML page without being online. So you can go to google.com, hit enter when you're offline, and you get a page, which was not possible before. But it's hidden behind all this centrally planned, very, very specific, very, very scenario-specific story. And really what you would like is the ability to just have that capability, access it directly. So how did we end up here? How did we end up in this situation? So let me go through how it works to access a web page using your browser. So let's say I type in yehudakatz.com. I hit enter. So the first thing that happens in the current browser is the browser says, OK, I need to make an HTTP connection. And everything about that HTTP connection is completely hidden from you in JavaScript. It's completely hidden from you, even in any kind of higher level API. An HTTP request is made, eventually comes back, and you end up with a page being shown. A little bit later, as you're parsing the HTML, you're going to see an image. Again, the browser is going to make an HTTP request, completely opaque to you, make a request, come back, and then you get the image, right? So the important thing to notice here is that this whole thing is a black box. There's an HTTP thing going on, and it's completely opaque to you. So the obvious thing to do if you're Ian Hicksey and you're trying to add offline support is you say, OK, so clearly that part of the system is where offline support is needed. Let me add a new API, a new high-level API. Let's make it a manifest. And if you give me this manifest, I'm going to change my HTTP behavior to do something different. Unfortunately, the thing that he came up with didn't actually solve a lot of real use cases. So there was a number of seminars that were happening trying to essentially fix the problem called fixing app cache or fixing offline, many in-person seminars, workshops, et cetera. And one of the things that came out of this workshop was this ticket that was opened by Anna Van Kesteren that basically was targeting one particular scenario which is, I have a blog, I would like the blog to work offline. But when I'm online, I just want to go to the website. I don't want to be serving stale content when I'm online. But I want offline to work. This was reported in 2011. That was already way too late. That was already when there were seminars called Fixing App Cache. More than 6 months later, after a very, very long back and forth, Hicksey said, I've added the idea to WhatWG spec. Maybe it's implemented in some browsers now in 2013, a year later, but it's not implemented in all browsers. And it's really just one particular spot fix for one particular problem. And it took an entire year to even make a little bit of headway after everyone already agreed that it was so broken that we needed to, again, have seminars. So this is not really, I don't think this is tenable. I think everyone knows after doing this top-down centralized planning way of adding new capabilities to the platform, the platform people, browser vendors in particular, are very frustrated by this. I think people feel trapped by the fact that they know they can't break the web, so they can't iterate fast. But on the flip side of that, they know that if they don't iterate fast, they're losing ground to other platforms. And so there's a strong problem, and this is the answer. The answer is something like what Alex Russell from Chrome announced recently, which is the navigation controller. So this is his repo. Notice that he put a repo on GitHub, and there's many issues that have been opened, and there are pull requests, and there's open discussion. You look like you have a question? No? Okay. It's an open discussion about a new feature, a lot of back and forth that happened. It's a low-level feature. And how does this low-level feature work? Well, what happens is, when I type in yehudakatz.com and I hit enter, what happens is, the first thing that happens is we check to see if there's any JavaScript code registered. Now, this JavaScript code obviously does not run inside of your page because that would be a chicken and egg problem. This is JavaScript code that runs outside of your page in what is called a shared worker, so another thread, basically. And the page says, OK, controller, do you have yehudakatz.com? And probably what the controller will do at first is it will say, no, I don't have it. Go make a normal HTTP request. HTTP request is made. HTTP request is returned, and we're back in business. So note the difference between this and the old model. In the old model, we still had this capability, but that controller was completely opaque. It was something that someone had to decide in the W3C, someone had to make a standard about it in order to make this work at all. And now what we're saying is, let's stop trying to figure out all the use cases up front. Let's just expose that capability. We already know we could expose it securely. We already know mostly that we could expose it efficiently. But we should just stop trying to guess, because we're guessing wrong. We're constantly guessing wrong. And then what happens when you get to an image? So similarly, you go to the controller, you ask the controller makes a request to the server, returns, and then you show the image. So far, this is pretty much identical to what we had before. Actually, what we had before, even without offline support. But let's look at how offline support might work. So offline support might work. You go to yehudakatz.com, you hit enter. And maybe the controller already has something cached. Maybe it doesn't actually care if you're offline or not. Maybe it does care if you're offline. This is just JavaScript code. It could decide to do whatever it wants to do. It could decide to implement that. I always want my blog when I'm online to go to the server, but I always want to store from the cache when I'm offline. It has access to caching primitives, right? So now we can actually figure out what the requirements are. We can figure out what the requirements are in a way that allows us to iterate quickly, and we can figure out what the requirements are without having to go back to Hixie and convince him about some particular edge case. And if people don't like where it ends up iterating, they can just keep using the old JavaScript library. So it works the same way. And again, images, go to the controller, come back, and show the image. So the important thing here is that this is not saying that we don't want app cache, right? So app cache had the nice property of being a manifest. It had a lot of semantics around atomicity. That sounds great. It's great for us to have features like app cache. It's even great for browsers to be inventing the ideas of how those things should work. What's not great is for the standards process to have a monopoly on how you're allowed to use these new capabilities. Also, if there are domain-specific problems, like I'm trying to be a blog, or I'm trying to be Facebook, or I'm on Wikipedia, or I have some math-specific stuff that maybe has different offline requirements than if I'm showing code. Maybe Ruby code or Java code in the browser, an editor might have different offline requirements than a blog. And this allows us to actually explore all those spaces. It allows you to have a library that's maybe for doing offline code editing, that does specific offline support for that use case. And maybe over time, we find that there's a lot of commonalities. Maybe we put that stuff in the platform. But we don't have to worry that we screwed it up, that it's in the platform and now it's too late. So I think this is a really good example of where things are going in general. It's with looking at, OK, we have a new capability. We want to expose this new capability. Let's stop trying to guess. Let's just expose the low-level primitive and let the ecosystem figure out what's up. Another really strong example is custom elements. So you might have heard of the Polymer library. If not, check it out. So this is a Google library that they created basically to flesh out the idea of custom elements because of the fact that the standards process was just taking too long. So Google had an idea for custom elements for data binding, and they were just having trouble getting it to move quickly through the standards process, probably for good reason. It was a big, complicated project. And what they did is they said, OK, we're just going to write a JavaScript library. It's going to be very invasive because that's how you have to do some of this low-level stuff today. But we're going to show everybody how it works. We're going to iterate on it. We're going to let the community figure out what's going on. And then we'll eventually move it back into the standards process. Polymer. They announced it at Google I/O, actually. So this is actually sort of my personal end goal for custom elements. If you don't know any JavaScript, that's fine. I'll try to walk you through it a little bit. So first of all, the top two lines are a new import syntax, which is coming from the JavaScript side. So this one slide actually encapsulates a lot of things that are coming in the future that make it really easy to do more low-level stuff without getting super invasive. So importing from packages or modules is a thing that's coming very soon. It's coming in ES6, so we can basically not have to store everything on the global. That's great. That's a good starting point. But then you can see here class syntax. So that's also new, class syntax. But what's really cool about this is that you're extending a native element. So even today with fake classes, the JavaScript fake classes that use prototypal inheritance, there's not really any good way to subclass HTML elements because they use this internal C++ struct, and you really can't get access to it. So part of the process of creating classes as first-class things in the language is also figuring out what it means to subclass raw elements. So in this case, I'm subclassing a canvas element. And the canvas element is just a raw drawing context. So we have things like images, like divs, we have SVG. But the platform also today, in 2013, and for quite many years before that, has a thing called a canvas element, which is just draw whatever you want. And so what we've done here is we said, OK, I'm going to register a new tag called custom image, and here's the implementation. It's a subclass of canvas element. And what we're going to do is as soon as the tag is inserted into the page, and that's going to happen when custom image is seen by the HTML parser, it's going to go call that ready callback. That ready callback is going to make a request to fetch. That's going to return a stream. It's going to pipe that into something that converts it into an image bitmap stream, pipe it into the canvas, and call it a day. So why is this cool? So obviously, first of all, you could actually do basically this functionality today using a lot of JavaScript. So you could go scan the DOM looking for stuff when things change. You could try to use mutation observers to notice when things get added. You could trigger your own callbacks. You could make AJAX requests against some source, and you could try to convert it into a stream using some function. You could use another API to draw, right? But all that actually has a lot of tax. It's very heavy. It involves a lot of different APIs that may compose poorly with other things that are happening on the page, where this is really isolated. This is basically a very low-level mechanism, but It's a very low-level mechanism that does pretty much exactly what you want. And actually, one thing that is interesting about this fetch method, so something that you may or may not know, is that in the browser, when you make a request for some data, you basically have two options. You make a request for some data using something like XHR, which lets you see the response. And if you do that, you could only make requests to your own domain or domains that have opted in. And then you could also just use an image tag directly. And if you do that, you can make the browser will basically handle all of the stream, all of the image data, but you can't look at it. So you can get an image on the screen with a cross-domain image. That's how script tag works the same way. That's how you put in advertisements or whatever. But you can never look at the contents. And the interesting thing about this fetch API here is that this fetch API actually has the ability to return an opaque stream. So the opaque stream is basically something that works pretty much like the image tag. You made an HTTP request, was totally legal to make it, you can't see the contents, but you can pipe it directly into some other primitive that knows how to handle it. So the specific details here are not that important, but what is important is that the idea is that we're really getting into the low level. We're not breaking the security model, right? The security model is very important, and we don't want to break how the web works. But we do want to get as low level as possible to give you the ability to re-implement image, to re-implement script tag, to re-implement audio tags, to re-implement input type equals range. We want you to be able to do all these things, but to do that, we really need to stop exposing all these capabilities as some particular side effect of executing some markup, and really just give you the low-level feature, give you the low-level API. So I think where things are going in general is that the standards process is increasingly focusing on capabilities, on brand new capabilities, giving you access to hardware, giving you the ability to hook into the HTML parser, maybe giving you the ability to hook into CSS itself, which is a much harder problem than any of this. And we need standards bodies to do this because we don't want to get access to the low-level features in inconsistent ways. We really need the browsers to get together and talk about how to do it. We want the things to be secure. We want them to be efficient, right? So we really need standards bodies to focus on capabilities. On the flip side of this, increasingly, developers are using the capabilities that are given to us to iterate on higher level APIs. We've seen things like people have built things like mscriptin, which takes any C code and compiles it into JavaScript. Now, you might think that that was always possible, but it really wasn't. It required a bunch of new APIs around low-level memory management. So there's an API called array buffer, which lets you basically allocate a big blob of memory and just write into it efficiently. So we have a lot of these things that are starting to happen where developers are using these low-level primitives that are given to us to iterate on higher-level APIs. And increasingly, the standards bodies are getting cut out of the process. Nobody really standardized mscriptin, which is the thing. It's an LLVM thing that takes anything that goes into LLVM and dumps out JavaScript on the back end. Nobody standardized that. That just happened because of the fact that the primitives were available. And in fact, that whole process, it's good that it wasn't standardized because it's been iterating a lot to get improvements, to work with ASM.js, which is a standard. It's a way of getting very, very good performance out of a subset of JavaScript code. So what we really want is we want these low-level primitives, and then we want to let the developer community go to work. So this is a Java conference. I think Java basically did this. I think Java early on decided that they weren't going to focus so much on a lot of high-level APIs, but more about just giving low-level primitives that are needed. And now the MLVM project, the things like invoke dynamic and giving access to a whole bunch of new features are also continuing that process of saying, we know that a lot of people are building languages on top of the JVM. Let's not try to guess what those things are. Let's just think about what low-level primitives that we need. And that's increasingly happening in the platform, the web platform. And one thing that I think is sort of the missing piece of this discussion in general is essentially what happened with Polymer. So when you start off thinking about this topic, there's sort of a weird gap, which is, so you could imagine a browser implementing a low-level feature like array buffer, and then supposedly the developer community is supposed to do something with it, but that really involves developers taking some time out of their day to look at the primitive and try to figure out what is going on here. What is the point of this? What does the browser want me to do with this? And what's increasingly starting to happen, so mscriptin is actually a project that was heavily funded by Mozilla, also ASM.js. Polymer is heavily funded by Google. What's increasingly starting to happen is that browsers are saying, we've given you these primitives, and we have a good idea of what we think you should do with it. We have some ideas for a high-level API. Now, we could just go put these things into the browser, but we're afraid, we don't want to make mistakes. We've made too many mistakes already. So what we're going to do is we're going to write a library like Polymer, like mscriptin, And we're going to give it to you, the developer community, and help us work on it. And maybe in a few years, if we iterate enough and we realize that there's a lot of consistency around what we've come to and there's a lot of agreement, maybe then that's a good time to bring it into the platform. Maybe that's a good time to avoid downloading a lot of JavaScript that everyone has to download. And you can see some of that happening with jQuery, actually, in sort of on a different level. Increasingly, features that jQuery required, like the ability to match on selectors, to find things by selector, a bunch of DOM APIs. Increasingly, these things are actually added to the platform. So you shouldn't necessarily expect that things are going to be adopted whole hog, like just standardizing jQuery would be a little bit crazy. But looking at what it is that these libraries are doing is crucial. And I think I just want to repeat the fact that one of the biggest wins for this is actually not for things like jQuery, which are very generic. And in theory, the platform could do it. You get away with it. You have these big libraries. It's fine. What this stuff really does is it allows domain-specific communities, little communities that are working on things like math, things like code, to build their own abstractions. So today, if you want to build a code editor or something like that, it's not going to be easy to do it using markup. So if you want to put Ruby in the DOM or Java in the DOM, it's not so easy to do it using markup because we don't really have good tools for it. We're going to have to use spans with classes. It gets super ugly. People don't really want to write that. But with new tools, with web components, which lets you write custom elements, with hooks into the parser, with low-level drawing APIs, maybe hooks into CSS, you could easily imagine that little communities that have no business getting things standardized through the W3C will be able to build their own little jargon, their own little vocabulary for their own stuff in high-level ways. And I think ultimately, what is extremely crucial is I talked a lot about low-level JavaScript APIs, but really, this is not about low-level JavaScript APIs. This isn't about everyone writing a lot more JavaScript. Really what this is about is helping a few people build high-level APIs for everybody else, right? So jQuery didn't make it so that everyone wrote more JavaScript than if they were writing using DOM. jQuery made it easier to write less JavaScript by using the tools that were already available. And especially when you can hook directly into the declarative forms, when you can hook directly into markup, I think we'll definitely see increasing numbers of people that build for their little community enough tools to move forward without having to involve the standards process. The web basically got started with the radical idea that document authors shouldn't need permission from a central authority to publish things. Why not apply the same ideas to the standards process itself? Thank you very much.